My name is Luay Abdelkader. I work in BlackBerry QNX in the product management team. I'm the product lead for the QNX software development platform. The market trends for the automotive market, industrial, medical, and other areas as well is showing that the next generation systems are going to be relying on extremely powerful hardware. Whether it's SoCs coming from different silicon vendors worldwide or SoCs that are custom made in-house, the next generation hardware is going to support 16 cores and up, whether it's 20, 30, and potentially more. And that means that for embedded systems, the operating system that runs on top has to be extremely powerful to utilize and harness the power of the hardware that's going to be provided. The reason why this is all happening is because of consolidation of systems and, of course, software-defined systems that are coming out. The automotive market is leading that charge with software-defined vehicle, with ECU consolidation and high-performance compute being at the center of it. QNX Software Development Platform 8.0 is here to answer the challenge for these market trends and here to answer the industry needs. The QNX SDP 8.0 has three main components. Number one, of course, is the QNX operating system. At the heart of the QNX operating system is the microkernel. The QNX microkernel for SDP 8.0 has been augmented to really optimize and utilize the next generation hardware. We've redesigned the kernel to harness the next generation hardware. And of course, we've upgraded and enhanced all the features that come with the QNX OS. That includes the networking stack, file systems, security features, safety features, the tool chain, graphics, Wi-Fi, and more. All of that has been upgraded to the latest and greatest standards and technologies that the market is looking for today. The other parts of the QNX SDP include the QNX Toolkit. In the QNX Toolkit, we have three components that are really essential for developers. Number one, of course, is the QNX Momentex Integrated Development Environment. This is our proprietary solution for the IDE, and we've done a lot of upgrades in it to really harness the latest technologies and reduce developer friction. The second component of this QNX SDP 8.0 is the QNX Tool Suite. There are three main components in the QNX Tool Suite. Number one, of course, is the QNX Momentex Integrated Development Environment. The QNX Momentex Integrated Development Environment has been upgraded to really enhance the developer experience and really harness a lot of the technologies and standards that is available today. We're also releasing the QNX Toolkit, which you can find on Microsoft Visual Studio Code Marketplace. Really, the QNX Toolkit is an extension that's available for Microsoft Visual Studio Code. So if you have developers in your team who are used to using Microsoft Visual Studio Code, they can download and use the QNX Toolkit and have parity when it comes to a feature standpoint with the QNX Momentex tools, the QNX Momentex Integrated Development Environment. Lastly, the QNX command line tools. We have a lot more command line tools and utilities that are available with SDP 8.0 to really let you be able to troubleshoot, profile, and analyze your target systems more effectively using the greatest utilities and technologies available in the market today. We have, lastly, the QNX Software Center that's available. The QNX Software Center allows you to have a central repository to manage your installations, updates, and license management. We've done a lot of feature improvements in it to really enhance the user and developer experience. In this demo today, we wanted to showcase really the value proposition of SDP 8.0. And the value proposition of SDP 8 really is performance while maintaining and improving the real-time safety and security features that QNX is well known for in the market today. So, showcasing an embedded OS demo at CES is really a challenge to really try to highlight the performance and scalability and, of course, real-time execution that QNX is well known for. But we have a very clever way to showcase that. In this display, which is, by the way, using Unity, we have a cockpit, but what you're used to seeing speed and RPM in any cockpit in a car, what you see here is the OS operations per second and the CPU load. And here the gearbox, instead of seeing the gears that you're used to seeing in a car from 1 to 6 or 1 to 5, we have the number of cores available: 2, 4, 8, 16, 32, and 64. This demo is running live on Amazon's AWS, specifically the Graviton 3 hardware, which is the latest and greatest hardware that Amazon has to offer. It's running on a 64-core instance in the cloud right now. We have multiple scenarios running in the cloud on SDP8. We have signal processing. The rationale behind that is, as you consolidate ECUs into a really powerful central compute, you have a lot of sensors in the card that is pushing data to that central compute that you want to be able to process and analyze very efficiently and effectively. We have the calculation of pi. Pi is an irrational number, and the calculation of it is really cumbersome and CPU intensive. So we have the calculation of pi to highlight and to showcase that if you have something that is very compute intensive, you'll be able to utilize that. And lastly, we have TensorFlow. We've ported TensorFlow over to QNX to showcase that you were able to utilize AI and ML algorithms running on QNX for autonomous driving, whether you're trying to reach level 2, 3, 4, or in the future 5. So these scenarios are all running. The graph here is showing the operations per second based on the number of cores that you're using at a given instance. I'll wait a few seconds for the demo to run through. It's running automated. So as you can see here, the demo is running in an automated fashion, switching between different cores, and you can see here the CPU loads are changing. I will pause here. What we're trying to showcase in this demo, as I mentioned previously, is the performance and scalability of this new OS. So if we take an example of the 8 cores, the throughput of the OS is around 107,000 operations per second for the scenarios that are running in the background. When you go to 16, the throughput of the OS jumps to 211,000 operations per second. As you double the number of cores, you're getting double the throughput. When you go from 16 to 32, it jumps to 417,000 operations per second. Again, doubling the number of cores, double the throughput. And when you go from 32 to 64, it jumps to 835,000 operations per second. What we're trying to show here is with our new kernel design and implementation and all the upgrades we've done to the OS, we have linear scalability as you increase the number of cores. That is something that is unprecedented from a performance standpoint, especially in an embedded system. And this will really let customers and our partners utilize the next generation hardware to its fullest. Of course, QNX is known for its real-time behavior. So we also have real-time events that we can generate while the scenario is really pushing the OS in the cloud. When I press this button here, I'm generating alerts and interrupts for the OS to handle very quickly. High priority interrupts and alerts for the OS to run very quickly. So I'm launching a few here, and what you see here in this display is the timing associated from the moment the interrupt was raised all the way to the interrupt being finished. And what you see here is the servicing of the interrupt is extremely precise, extremely accurate, which highlights the determinism that you're known to expect with QNX. Of course, QNX is a hard real-time OS, and the accuracy goes down to the nanosecond level when it comes to timing standpoint. QNX has a lot of other safety and security features with the OS. You can find that on the QNX website. If you search for SDP 8.0, you will see all the security features that are available. The safety certification for QNX SDP is coming in the upcoming months. We are, of course, going to safety certify the product to the highest safety integrity levels for automotive, industrial, medical, rail, and other standards as well, to really allow customers who want to use QNX in high performance and safety critical systems to be able to utilize QNX to its full potential. We also have additional products that are coming, including the QNX Hypervisor and the QNX Container Initiative that is going to be available in the coming months, so please watch out for more announcements. If you want more information on QNX or SDP 8.0, please go on the QNX website for more information. We have the product brief for SDP 8.0 there, and we have steps if you'd like to evaluate the product. Of course, if you'd like to have more in-depth discussions, please reach out to the QNX team and we'll be able to help you as soon as possible. Thank you.